So here we are going to talk about the acids basis chapter. So we start our discussion with the understanding of what an acid is by definition. Acid is a proton donor, or it is a substance that releases H plus ions. Generally, you will find all the substances that has H in it are termed as acid. So hydrochloric acid, HCl, H2SO4, H3PO4 is phosphoric acid, HNO3 nitric acid, examples of acid. Acid classified into strong acid and weak acid. Strong acid it dissociates completely, which I have shown here, HCl transforming, getting dissociated into H plus and Cl minus. There's a 100% dissociation which is seen in them. They are strong acid. Weak acid does not dissociate completely. They dissociate partially. So here, as I have mentioned, they are not dissociated and they are reversible in nature. Ethanoic acid, which is represented by the formula CH3COOH, is a weak acid. Similarly, if acids are proton donors, base by definition are proton acceptors, or in other words, these are substances that releases OH minus ion when they are reacted. OH minus ion is called as hydroxide ion. Hydrogen atom, let's understand something. What is a proton? Proton donor we are talking about. In hydrogen atom, when this electron goes during a chemical reaction, you are only left with one proton. So similarly, whenever we are talking about H plus ion, H plus means it has lost that one electron. It is equivalent, it is proton only. So hence we are calling it as proton. Hydrogen atom, which has lost its one electron, is only left with one proton, isn't it? So hence we call it, either you call it hydrogen ion or you call it proton.
Is the microphone on?
Yeah. So base can be classified into two categories: strong base and weak base. It dissociates completely. Strong and same way what you saw in the case of acid, and in weak base also it is similar. It is dissociating partially and it is reversible in nature. Examples are very important. Sodium hydroxide is a strong base, whereas in the weak base side we find ammonia. Now this example is something that I have seen that everyone keeps forgetting. Please keep in mind that weak base example is ammonia. Now ammonia is highly soluble in water, and hence in this example I have shown it along with water. NH3 combines with H2O, which results in the making up of NH4 plus ion. Now majority of the cases I have found people forget about the name of this NH4 plus ion. Do you know it? NH4 plus ion is ammonium. Now, I would highly recommend that you please keep this in mind, and OH minus is released. In other words, if you see NH3 has accepted H plus ion. It's a proton acceptor, and hence it is a base. Proceeding ahead, we find in acids and base, one difference is also about the pHs. If the pH is between 1 to 3, it's a strong acid. If it is 4 to 6, it's a weak acid. 7 is neutral, 8 to 11 is weak base, and 12 to 14 is a strong base. Actually, 11 to 14, I would say, is a strong base. Uh, so it's a continuation, like 4 to 6.9 also will be in and only when it becomes 7, then only you will be calling it as neutral. So this is the data pH wise that you need to understand. pH stands for the power of hydrogen. Indicators which are used, indicators are what now? Indicators are special kind of substances which change color whenever there is a change in pH happening. Indicators are helping you in chemistry lab to identify substances as acid or base. It could be a fruit juice, it could be any other organic substance. We are just interested in their color change. If the color change is happening, that thing is accepted as an indicator. Now over here you have three indicators whose color change you have to know by heart. You have to remember this. Litmus in acid is red in color, and in blue it is blue in base, and phenolphthalein is colorless in acid, and in base I have made a mistake. I have written, instead of base blue, I have written phenolphthalein is pink in the base. Methyl orange is red in color, very similar to what litmus was in acid. Methyl orange is red and yellow. It's, although you are naming it as methyl orange, but it is not becoming orange in any of the two scenarios. But yeah, methyl orange in neutral solution is orange in color. Okay. And then there is one more indicator which is important. We call it as universal indicator. What do we call it as? universal indicator. So here I have not written universal indicator, but I have written Vibgyor. You should understand that universal indicator shows you color in the form of means varying range of colors, like it's a violet, indigo, blue. Green it shows for neutral pHs, and if your pH is very strong, then you'll be getting either violet represents the strong, and then if you get blue indicate that it is a weak base, and if you're getting yellow, that indicates that it is a weak acid, and if you're getting red, that indicates that it is strong acid. So this is how it is. Now talking about the neutralization, which is the most important concept in this. Neutralization is a reaction in which acid is combining or acid is reacting with base, and it forms salt and water in the process. So this is the general syntax of the neutralization reaction. Now we will understand what are bases exactly. Now this another thing which everyone keeps forgetting. I don't want you to forget. It is metal, metal oxide, metal hydroxide, and metal carbonates. These four things are base. Why are they base? Because base reacts with acid. All these substances reacts with acid. Metal plus acid. Okay, but one thing is there. We find that although all of them are reacting with acid, but only three of them could be termed as neutralization reaction. Why only three of them? Because metal does not give you salt and water. Metal when combined with acid does not give you salt and water. It gives hydrogen instead. Metal oxide gives you salt and water. Metal hydroxide when reacts with acid gives you salt and water. Metal carbonate when reacting with acid gives you salt water, and carbonate also gives you carbon dioxide. So that's a special thing that they give. So metal plus acid gives you salt and hydrogen, and this is what I have given with an example. Zinc reacting with hydrochloric acid giving you zinc chloride and hydrogen. Second, metal oxide plus acid giving you salt and water. Zinc oxide when it reacts with hydrochloric acid. So double displacement reaction is happening. Zinc oxygen goes to hydrogen and chlorine comes to zinc. That is what has been shown over here. Metal hydroxide, similar thing. The hydroxide goes to that H, and chlorine comes to the zinc, and zinc chloride and water is produced. And carbonate is a special case. You should understand that it is going to give you carbon dioxide. Acid base gives you salt and water. That's a basic thing. But if carbon dioxide is also getting high, it's okay. But the definition says that you need to have salt and water. And yes, all these three conditions, all these three things which are shown on the screen right now, they fulfill all the conditions of neutralization. Hence these three are neutralization reaction, but metal plus acid is not a neutralization reaction because it only gives you salt and hydrogen. It does not give you water. Okay, so 2, 3, 4 are neutralization reaction, whereas 1 is not a neutralization, as H2O is not formed in that case. Okay, now we find that in this process of neutralization, the product is salt. So we will be understanding that whatever salt is produced in the process, how are they extracted, how are they taken out. Now salt formation we'll be talking about. Salt formation, salt exists in two ways. One salt which is soluble in water, another salt which is not soluble in water. Now, not soluble or insoluble salts which are there, they are in the form of a precipitate. Precipitate, curdy kind of appearance they have. Okay, somewhat like this. The moment they are formed, they will make the whole precipitate filled with that solid thing. Okay, so we find that generally soluble salts you will be finding. So soluble salt, we find that these can be separated using the process of crystallization or evaporation, and here by filtration you can separate these salts which are produced as a precipitate. Yeah. The difference between crystallization and evaporation. See, crystallization and evaporation is see, you will be getting crystals in both the case, but in crystallization you are heating it, and evaporation you are putting it in sun, or you are just putting it in open atmosphere, so that from the surface the water keeps evaporating, and finally all the water evaporates. So evaporation is going to take a lot of time, whereas in crystallization case, in crystallization you are using Bunsen burner, you are heating it. Okay, but you are gently heating it, not very harshly. So that is the difference between them. So one place you are heating it. In evaporation you are just allowing it to evaporate whatever time it takes. You give that much time to it. So in both the cases you will get your salt if it has dissolved in any in anything in the solution, I mean to say. So over here we'll be talking about the bases. Now bases, as I said, base are what? Metal, metal oxide, metal hydroxide, isn't it? They are base. Now these bases, it could be they can be water soluble, but we also find that majority of the cases are not soluble. Like if I say copper, copper is a metal, it's not a solution. So what would you say? Is it soluble? Does copper dissolve in water? Copper is a metal, why will it dissolve in water? So you find base could be insoluble or it could be soluble also. Soluble base is called as alkali. What it is called as? Alkali. And insoluble base are the one you term it as bases only. So now we find that whenever bases which are insoluble in nature, whenever you do reaction with the insoluble kind of base, which includes copper, copper oxide, which don't dissolve in water, so insoluble kind of base when you use, you remove the excess of reactants. And whereas here you do the titration, you remove the excess of reactants in this case. So what happens, what is this titration process? Where you have soluble base, you have liquid base, you have liquid acid, then you follow a process of titration where you are adding indicator and all, and you are doing the reactions. Okay, so do you know, do you have any idea of these apparatuses?
Yeah.
What is this? Burette. Have you seen burette?
Yeah.
Have you seen anyone doing this investigation in school? Okay, so this is burette. That's pipette. Pipette comes of 25 cm3. That's a conical flask. Okay, and then what we do, using this pipette, you are going to take either acid or base, and then you are going to pour it in this conical flask. Then this burette you are going to, if suppose this pipette was filled with acid, burette me you will fill the base, and then drop by drop, or by opening this bottom nozzle, you are going to take drop by drop. Oh, before you start putting it drop by drop in the conical flask, you are going to put this thing, the indicator in it. Indicator, I just showed you, phenolphthalein, which is generally colorless in acid. So if we put acid, it will be colorless in nature. Then drop by drop, if you keep putting in, there will be a point where one drop of the base, which is falling from the burette, will make the color change happen. The colorless will turn into pink. The moment that effect you see, you stop the reaction and you take the reading. All these details I have mentioned over here. Okay, so I'm giving some time. You can pause the video and you can check it. So it's the same thing what I just said.
Me.
Yeah, it so over here also mentioned. So you can repeat the experiment without the indicator, because indicator is causing. So once you have done this experiment, you have got that what amount of for 25 cm cube of acid, how much quantity of base is needed. Once you come to know that, then you can repeat the experiment without the indicator next time. Okay, and then you can do the crystallization process or you can do the evaporation process. Now comes the point that what is the crystallization process? Crystallization is a 5-step reaction which I have shown on the screen. Okay, so what is it? You are going to gently heat the solution until it is saturated. What is the meaning of saturated?
Meaning it's reached its and it can't dissolve anymore.
So saturated means the maximum level.
Much.
Yeah, means there are less amount of solvent and more amount of solute. In other
Question.
words, yeah,
Can
see,
you go out?
yeah.
Yes, hang on. So here says bases that are soluble, but what is it dissolved in?
Soluble. They are dissolved in water.
Oh,
Everything remains dissolved in water.
so then how's this gonna help?
What?
How's titration gonna help?
Titration is going to help you to understand that solution. See, everything has a concentration.
Yeah.
Everything has a concentration. So that concentration is going to help you
But this is,
to
aren't you just gonna neutralize the bases? How?
using the acid. Yeah, so you will be have see, you will come to know that this kind of concentration of acid with this type of base which is having concentration of so and so, how much quantity of this is needed with that. So it's like very relative. Okay, you can't say that it is always the scenario like that. No, it is very relative. Okay, so what happens? So finally, when the change happens, the color change happens, you repeat the experiment without the indicator, and then finally you would be you will be knowing that yes, it has solved. The neutralization has happened in it. So you are going to follow the crystallization process where you are gently heating the solution until it is saturated, and then you allow the solution to cool. Crystals are formed at the bottom. You filter the crystals out. Once the crystals are separated from their from the means once they are taken out, what you are going to do, you are going to wash it with distilled water, because distilled water is pure, right? and then finally you're going to dry. You can dry it using filter paper also, you can dry it by putting in oven also. Okay.
Okay, why are you washing the crystals?
Because there could be some traces of the extra base. What if more base has been added? There could be some traces of, see, salt is salt, salt won't have base inside it, but there could be some traces of base over the salt surface. Do you want that? No. So we are going to wash it with distilled water, and water is neutral.
Hmm.
Salt is also neutral
Yeah.
because they are formed of the process which is called as neutralization. Okay, so now second thing, here we have the base, which is zinc is a metal, and it is insoluble base because it's a metal. How can it dissolve in water? You are going to put it in hydrochloric acid, but over here we say that we are going to use excess quantity of zinc, excess of the, so that the whole of the thing gets used up. So over here, when zinc combines with hydrochloric acid, it is going to give you hydrogen.
Yeah.
The moment hydrogen stops bubbling off, you'll come to know that the reaction has happened completely.
Yeah.
And then you go ahead and you remove the excess quantity of zinc. Okay, and then the filtrate would be a completely neutralized solution, and then you can follow the process of crystallizations as I have mentioned above. Okay, then salt identification process comes into frame,
Okay, one
so which
question.
we will not be talking
Uh,
as of now.
um, when you filter the salts, would
Yeah.
they already be like
Hmm.
they will already be crystallized, right? After you filter them?
After you filter them, in the filtrate you are talking about,
No, like when they collect out here.
that is zinc, the extra base with the acid. So
Okay.
hydrogens have bubbled off, but zinc
Oh
we
wait,
have
no, zinc chloride
intentionally.
mixes with water and then you crystallize that.
And then so over
Oh, huh,
here
yeah, yeah.
zinc chloride is there in the
Yeah,
solution
yeah.
form, and then you evaporate it, and then you get your crystals, you wash them, and then you dry them in oven. Okay, so in this way I have given you a complete understanding about the acids bases. Have a look at it.